A sagittal section of the head shows us the extent of the nasal cavity. This little space right here is the oral cavity, but this entire space up here is the nasal cavity. You can breathe through the oral cavity, but it's not as good as breathing through the nose. The oral cavity is really designed for eating, not inhaling air. One of the reasons that you want to breathe through your nose is olfaction, the process of sensing smells. Cranial nerve number one, the olfactory nerve, has dendrites that actually extend through the cribriform plates of the ethmoid bone and hang down into the nasal cavity. As air enters the nasal cavity, these dendrites send action potentials to the cerebrum concerning smells. This is why you might freak out when you smell something that smells like the dentist. Sorry, I didn't mean to laugh there. Everybody's afraid of the dentist. The nasal cavity is capable of some filtration of incoming air that the oral cavity cannot do. You have nasal hairs that are called vibrissae. They're macroscopic structures, and they are covered in mucus to make them even grosser, allowing them to trap large particulates that you might inhale. There are also microscopic structures, cilia, and those are little hair-like projections that come off of the epithelial cells lining the nasal cavity. These cilia are also covered in mucus and capable of trapping particulates. They then wave in unison in an effort to move the mucus toward the opening of the nose called the nasal vestibule. The nasal cavity is lined with the respiratory mucosa that we also refer to as the respiratory membrane. It's continuous all the way down your trachea, bronchi, and all the way into the lungs. It is a mucous membrane, one of the four of the body. These folds right here are folds of the mucosa that are covering the nasal cavity. It's not just a big open void. There are structures in the nasal cavity that warm and humidify air. Two things that you want your air to be as you inhale it. These are two of the benefits, warm and humidified air, that breathing through your nose offer, in addition to that olfaction and filtration that it does. On a frontal section of the head, we see these twists and turns in the nasal cavity. These twists and turns are formed by the nasal conchae, and then they're lined by those nasal mucosal folds. All of this creates a really cavernous environment, or a cavernous nasal cavity, in which air gets trapped and forced to kind of recirculate just a little bit longer than it would before being sucked down into the pharynx through the windpipe and into the cul-de-sac of the lungs. As the air circulates in the nasal cavity, it's exposed to these capillary plexuses that they're just under the respiratory mucosa, and this allows the air to receive that heat and that humidity from your blood. The nasal cavity, as with all open spaces in the body, is lined with an epithelial tissue. This epithelial tissue in particular is pseudostratified columnar epithelium. Recall that this type of epithelium has columnar-shaped cells. They all touch the basement membrane, making it just one layer of column-shaped cells, but these cells have all toppled over onto each other, therefore making them look stratified, or many layers, but they are not. Cilia are the little extensions that are like extracellular hairs that project from the apical surface of the cells. All of the big bubbly ovals here, like this one, there's another one here, those are mucus cells that were once called goblet cells. Their new name mucus is more fitting since they secrete mucus. These mucus cells, they exocytose their mucus onto the apical surface of the pseudostratified columnar epithelium. So all of these open spaces here in the turbinates or the nasal conchae are lined with that pseudostratified epithelium with cilia and a mucus lining. Sinuses do not contribute to the conduction or exchange of gases during respiration, but they are considered to be part of the respiratory system. Sinuses are open areas, fully embedded in bone, and they're intended to lighten the skull because they're filled with fluid instead of being filled with brain or bone, I guess, right? Because brain and bone are heavier than being filled with fluid. So the purpose of sinuses is said to lighten the skull. The sphenoid sinus is embedded in the sphenoid bone. The frontal sinus is embedded in the frontal bone. The maxillary sinus is embedded in the maxilla, right? And this is why if your doctor suspects that you have sinusitis or a sinus infection, they may push on your forehead or push on the bridge of your nose to see if it causes pain. Sinus infections are commonly caused by bacteria invading these open cavities. They can be caused by viruses as well. As a defense mechanism, your sinuses will begin to weep more fluid into the open spaces, and this causes the filling of all of these open spaces and the pressure that comes with that additional fluid. Sinus infections are officially called sinusitis, whereas infections of the nasal mucosa are called rhinitis. And yes, the word rhinitis derives from the same word that rhinoceros does. All of the structures of the nasal cavity, the mucus cells, the blood vessels beneath the surface, the conchae and the meatuses, they all contribute to warming and humidifying air as it enters your respiratory system. Have you ever felt like saying, wow, the cold air just took my breath away when you go outside in the dead of winter when it's single digits and you breathe through your mouth, right? You're like, oh, took my breath away. Cold air inherently holds less moisture or humidity than hot air does. And this is why it only gets humid in the summer. But had you taken that breath through your nose, the air would have been subjected to more time in the nasal cavity and more exposure to all of those features that warm and humidify it before it descends into your trachea, bronchi, and lungs. And this is also the basis of suggesting that athletes breathe in through their noses and out through their mouths in an effort to warm and humidify their cold, dry air.